And we are studying volumes of revolution. So integrals give you area. We're going to revolve that around an axis or a line, and we're going to create a three-dimensional shape. Okay, this is kind of an illustration of visually what we're doing. Okay, don't worry about shells. That's a Calc BC. Okay, all we worry about is discs and washers. So you know what a disc is? Yeah, frisbee, and a washer, like using in tools. Okay. So basically, we're going to start today with discs. So if I take, you can calculate that area, correct? Okay. If I revolve it around the y-axis, it creates a disk. And you have a three-dimensional object. Okay. What shape does it create? A what? Yeah, a circle. So what's the area of a circle? Pi r squared. So pi r squared is going to form our basis for volumes of revolution. It's just another formula, basically, and you plug your function in and go, right? We can also do interesting. Okay, let's reset here. We can also do disc washers. Get this fired back up. If I revolve that around, I get a washer. It has a hole in it. So all you have to do is a subtraction problem. Okay, you subtract out the hole. Right. So does that give you kind of a good idea of where we're headed visually?
Yes.
Okay. Delcia, you had a question.
Oh, yes. The base 1 plus base 2 in trapezoidal, is that the y-axis? Okay, thank you.
It's because you're doing your homework while we're not. Okay. So.
Good.
I feel like that's always a good place to start.
Okay, so there's a function. If I want to revolve that around the x-axis, it creates a circular shape. What's the radius of that circular shape? Let's just call that the square root of x. What's the radius? Yeah, it's the y value. Okay. So if I want to find the area of a rotated circle at any spot on that function, I'm just going to plug root x in there. So if my x value is 1, my area of that circle rotated there is pi. Okay. So basically this leads us to, yeah, that would be just for this specific. Now if I wanted, and then if I wanted to find the whole volume of this shape, right, I would have to take the integral from a to b, whatever that is. Okay.
Or R would be the Y value of V.
Because it would integrate all those circles and create a volume. So in general, volume is, I'll put the pi out front. And your radius is the function. Okay. Keeping in mind, that's the x-axis, if we're revolving around the x-axis, okay? So it's just another formula for us to use. Let's do an example. So we're going to calculate the volume, V, of a solid obtained by rotating the region y equals x squared about the x-axis from 0 to 2. So that's x squared from 0 to 2, right? And I want to rotate it around the x-axis. So what's going to actually look like, your book has a lot better pictures than I draw, but it's kind of a cone or a funnel, yeah. It creates a cone or a funnel shape. So for like computers, it's a lot easier to program a two-dimensional shape. And if you need to find the volume of that, you can, if you need a 3D shape, you program a 2D shape and do some calculus on it. So how do I calculate the volume?
Find respect for the Y to X.
Yep. You can write x to the fourth if you're okay. Because, well, here's your formula. Take the function and square it. It's, remember the circle, you're rotating and making a circle. So our formula is pi r squared. The radius is the function, so we had to square it. And execute. Hey. Okay. You okay with that? Anybody not okay? Okay, so that's called a disk. Because it has no holes. Okay.
Let's look at a washer. Okay, this would, if we rotated this about the x-axis, it's going to be called a washer. Any ideas on how to do that one?
Just for both of them and subtract it.
Yep, pretty much. You know how to find the area of that, you subtract, right? It's the same idea. So the volume is pi
Is that just the volume equation for all?
So basically, you're looking for the higher and the lower radii. So in our case, with the picture, it would be f of x squared minus g of x squared dx in this case. Sorry, I have those backwards. Yeah, g is on top. Yep, and f is on the bottom. The book is opposite there, but do you need me to show you an example? Yes or no? Okay. So find the volume V obtained by revolving the region between y equals x squared plus 4 and y equals 2 about the x-axis for 1 to 3.
Yeah, must be right. Then you can just plug it in, plug the equations in, and then you have to do one decision.
And there's kind of a picture of the region. X squared's on top. It's 2. We'll get to that one tomorrow. Or Friday.
That makes sense because one is the person for.
Okay, so volume. Pi, integral from 1 to 3. And we have 1 here, 3 here. X squared plus 4 squared minus 2 squared dx. How'd you deal with that? Yep. FOIL first. So and finish. Yeah, it's 16 minus 4. And you get your answer if you finish it. We're about out of time, so I don't want to. You guys can use calculators and do integrals pretty well, so. Do you have any questions? What? 42. Yep. Yeah, that's where I'm getting to. Okay. This is what I've shown you. It's where a majority of the work is in this section. Friday, we'll do this part B if you're going to be gone for basketball or something. Next Tuesday, yes, I'm very aware that juniors, you have park. That's the whole section. It's not due until Wednesday. Okay, so you have a week. Now this is kind of, some of you have some AP study session stuff to do, kind of giving you a break there. But try to work on it in the next few days so that you don't get behind. Tonight, tomorrow.
I need to see the following students when the bell rings. Allie, Beasley, Connor, Wayne,